In a previous segment, I mentioned that some quantities just need a direction, and some things in nature just don't. So we're going to dive in and we're going to be talking a lot about forces here for the next little while. Let's think about a force. Is direction important for a force? Well, it is. Why? How do I know that? Well, if I exert a force on this ball, the resulting motion, what the ball's going to do, it's just different depending on the direction, right? I probably don't have to try too hard to convince you of that. If I push on this ball in this direction, it does that. But if I push on it in the other direction, that way, it does that. Its resulting motion is just different. So what is a force? Well, a force is a push or a pull in a certain direction. Because the direction is so important for understanding forces, we call it a vector. So anything in nature that requires a direction for a complete description is called a vector. And in a previous segment, we learned that the direction is important for velocity. That means velocity is a vector. Also, the direction is important for acceleration. That means acceleration is a vector. So, a vector is something that has a direction, and it also has a size. The size of that thing is what we call the magnitude. So the magnitude is an amount. So, for example, if I was going to exert a force on this ball, then I would say, oh, I'm going to exert a force on this ball. How much? I don't know. I'm going to put a half a pound of force on this ball. In what direction? In that direction. Okay, so a half a pound of force in that direction looks like that. Okay, what's the magnitude? 1/2 of a pound. What's the direction? Over yonder. Okay, so magnitude is the amount of the vector. For velocity, which is possibly the easiest vector to wrap our brains around, remember that speed is how fast and velocity is how fast and in what direction. That means that speed is the magnitude of the velocity vector. Acceleration is also a vector. Not only does the size or the amount matter, but also the direction. Remember from our free fall video, if I drop this ball, it's going to accelerate. It's going to accelerate at about 9.8 meters per second squared. In what direction? Downward. So, what is the magnitude? Right here. 9.8 meters per second squared is the magnitude. Down is the direction. I've also said that our typical convention is down we're going to call negative. So we could also write this, instead of just writing down, we could write negative 9.8 meters per second squared. Negative means down. 9.8 meters per second squared is the magnitude. We don't have a fancy name for the magnitude of the acceleration vector, the way that we do for the magnitude of the velocity vector. But it's there, and it does matter. So force is a push or a pull in a certain direction, as previously mentioned. The strength of the push or the pull is the magnitude. Again, a half a pound. That would be a magnitude of a force. In what direction? Over there, or up there, something like that. The weight of me is actually a force. Weight is actually a force. Weight is the force of gravity pulling down on me. So gravity pulls with a force of about 175 pounds. In what direction? Down. 175 pounds is the magnitude. Down is the direction. Let's practice just a little bit. Here's a velocity, 100 miles per hour north. Which part of that is the magnitude? Why don't you go ahead and think about that for a moment, pause the video, and I'll see you on the other side. Okay, what is the magnitude of this vector? Well, remember it is the size. And for velocity, that is the speed. So which one of those is a speed? Is 100 a speed? No. 100 watts. 100 feet per century is a heck of a lot different than 100 miles per second, right? Those are two very different speeds. So 100 can't be it. How about 100 miles per hour? Ooh, That looks pretty good. I think 100 miles per hour is the magnitude. That tells us the speed. It tells us how fast. Which part is the direction? Well, this part isn't too bad. We're used to seeing north as a direction, and indeed, it's the direction here as well. So, our complete velocity is 100 miles per hour north. We need to have both of those pieces in order for it to be velocity. If we just have 100 miles an hour, that's just a speed, and if we just have north, that's just a direction. Together, they make a velocity.